Okay, well, I think we're ready to go here. So thank you everyone for joining us this morning, afternoon, or evening, wherever you are in the world, and yet again for another monsoon seminar series. So today we are joined by Dr. Binita Phartiyal, who is currently working as a scientist at the Bir Balsani Institute of Paleosciences in Lucknow, India. She heads the Paleomagnetism Laboratory, which is a national facility, and she received her early education from Nainital Institute in Uttarakhand, which is a hill station in the Lesser Himalayan zone. And she received her PhD in 2000 from the Kumaon University, also in Nainital. So she moved to Germany actually as a DAAD fellow at the University of Tübingen. And then after that, she came back and was appointed at her current institute at the BSIP in Lucknow. And so for the last 22 years, she's ventured into the Himalaya, the Gangetic Plains, and of course, polar regions for her research on climate, tectonics, the interaction with those with humans, geoheritage, and various analog studies. And she has supervised numerous students, conducted several training workshops for the field, and has, of course, authored many research publications. And she's a geologist by training, and so fieldwork is her passion, and this has led her into some of the toughest terrains in the world, including, which I didn't know this, Dr. Phartiyal, but this is really cool. So you're the first Indian woman to have taken part in an Indian scientific expedition to both the Antarctic pole in 2005 and 6, and the Arctic in 2008. And of course, you're very well known and you're still currently working in the Trans-Tethyan Himalaya part of the third pole. So thank you very much for coming today to talk about your research. And without any further ado, I'll, I guess, let you get started. And so, sorry, I should have said that if anybody has any questions, please type them into the chat, and then I'll call on you at the end of the talk, and then we'll have a little discussion from there. So anyway, thank you, Dr. Phartiyal, and I'll let you get started. Your mic is off here.
Hello, thank you, Tara. Thank you, and namaskar to everybody from India who have joined here for this monsoon series. And before starting, I would like to thank your team who have, invited me to speak on this. It's a wonderful platform that everybody would love to be on someday or the other. So I would be talking about the late Quaternary hydroclimatic variations in the Ladakh sector of the Northwest Himalaya. So as I was just introduced that, I belong to the hills, and mountains and the Himalaya have been my passion. And so I wanted to study the further areas of the Himalayan mountain range. So going to my next slide. Just a second, I cannot move to my next slide. Okay. Yeah. This is okay. Sorry for that. It always, technical glitches are always there. So today, how I have formulated my talk is to give you a very broad history of what has happened in the last late Quaternary times in this part of the world. This is the Ladakh region, the Ladakh Union Territory. This is a newly formed Union Territory. And I would like to start with a few slides on why we chose Ladakh to do the work. And the keywords that I would be revolving around are the geomorphology, fluvial and lacustrine sedimentations, and then the climate in which there is this multi-proxy data. And because we're talking about the Himalayas, so the effect of tectonic activity cannot be negated. We have to talk it because we want to know what were the, we know the endogenic, we know the exogenic forcings, but we want to know the endogenic forcings as well. So according to Köppen's scheme of classification, when we see the deserts, in the tropical areas. And when we see the Indian subcontinent, you'll see that India, it has a hot desert as well as a cold desert. So we will be talking about this portion, which is, where the altitudes are above 3,000 meters above sea level. It has very sparse vegetation and it is above the tree line. And because there is no vegetation to hold on, so it has a lot of physical weathering because of the extremes of temperature. The temperatures are like, in July, August, you could experience a 30 degrees centigrade, and in this month it was like minus 30. So there are extremes of temperatures, and a lot of signatures of neotectonic activity is seen in the region. And this region also comes under the third pole, as Tara just said. And this third pole is a very important area because, as we all know, that this encompasses the Hindu Kush, the Himalayan range, the Tibetan plateau. And it is the biggest, as an area, freshwater reserve apart from the poles. So that is why, it's known as the third pole. And this is also very important because 10 major rivers, the Indus, we'll be talking about the Indus here, the Ganga, the Brahmaputra, Irrawaddy, Salween, Mekong, Yangtze, Yellow River, Tarim, and the Amur Darya. They all originate from this third pole, and they feed about 20% of the world's population. So this area is, hot diversity. It's a hotspot, biodiversity hotspot. It also is very important because ethnic communities reside here. And when it comes to the trade routes, because we all know that there had been a silk route connecting the eastern part of Asia to Europe through silk routes, and some branches of the silk route were passing through the area of study. So it is very good area to study the human-climate interaction in the historic and the ancient times. With this, it has you can see a ecological diversity here. You have very cold conditions, in Ladakh. When you go in this month, you will see the landscape would be like this. There are hypersaline lakes like Sokar, and this is not snow, this is like a salt crust. And then you also have these hot water springs because Indus zone is there and the Karakoram fault is there. So along them, a lot of geothermal energy is coming up, and these are bubbling with like water with 80 degrees centigrade. So it's a great place with a nice ecological diversity where you can study psychophiles and thermophiles and halophiles. Lot of things can be done here. My love is for the sediments. So as far as the sediment diversity is seen here, you can find, because there's no vegetation, so everything, the slopes are blanketed with debris. There are deposits like these, which are the Paleolithic sediments. You can see here beautiful clays with a drop stone. You have a lot of aeolian, activity there, which is in form of the sand rams. You have sand dunes. You have fluvio-lacustrine sediments with very nice, sedimentary features. And of course, the slopes, because a lot of physical weathering is there, so it's blanketed with, debris deposits, colluvial deposit. And then also the permafrost, which is very unique in this area. And you see a lot of, permafrost just after 1 meter, 1.3 meter, you cannot dig further. The land is frozen. So, this is a typical, this picture is from Lamayuru, Paleolake. It is also known as the moonland. Moonland because it shows a lunar topography. You be there and you feel you're not in this world. It's like the moon here. So you can see beautiful paleo lines here. People have, a lot of researchers have been, people have worked there right from Burbank had published in 1987, Monnickford and Kotlia, lots of works from here. It is about 100-meter thick deposit, and all this, all throughout the years, that it has become a very, a bad land topography. So the age of this particular section is 35,000 to some 24,000 years before present, and it is at a height of 5,000 meters and very close basin, like a typical glacial lake. Now, when we see our area in cross section, you all know that the Himalayan mountain chain is 2,500 meters stretching from the from east to west. And then, if I just take you across this, we will see the outer Himalayas or the Shivalites, the lesser Himalaya, the higher Himalayas, then the Tether Himalayas, and then comes the Trans Himalaya of the place where we will be talking today about. So we'll be talking about River Indus and River Shyok, which is one of the main tributaries, right bank tributaries of the Indus River. So Ladakh Range is a range of mountains. This is like 350 kilometers like this. And it is between the, in the south is the Indus River, which is the backbone of the region. And in the north is the Shyok River. Okay, so this is the range, and this entire area, it receives, it's more of a westerly dominated terrain, and the rest of the Indian subcontinent, as we know, is it is more affected by the Indian summer monsoons or the monsoonal winds. But when the monsoon is strong enough, it has a higher intensity, it does penetrate into these areas to, and that sign is preserved. So this area in the Trans Himalaya, it forms an environmental boundary between the North Atlantic fossing, which is the westerlies, and the monsoon fossing, which is the ISF. So this location in this transient setting of these two climate systems, it is very good because it can attest the slightest of the change in the dynamics of these two components of the atmospheric system, and what we try to decode in the sediments. So this is the precipitation, east and west variation is seen, even north and south gradient is seen. So it is basically arid to a semi-arid place. So when we come to the river system, as I said, Indus River is the backbone of this region, and this is the Shyok River, which is its biggest left bank tributary. It joins Indus in Skardu, which is in Pakistan. So, our work is still the Indian boundaries here. And then all these rivers, they are following these Suchi lines and the fault lines, tectonically governed. And one more thing, that the Siachen Glacier, Shyok is being fed by the Siachen Glacier, which is one of the biggest or the longest glaciers outside the poles. So Siachen is feeding the Shyok River and the Nubra River, which are the tributaries of the Shyok. And one more river is coming from this side. It's called the Tangze River. So all these rivers, there's a network of rivers along the ranges of the along these ranges, along these Suchi zones and the faults. So I'll be taking you to this area and Indus River after this. So basically, as I said, because we were studying the sedimentary deposit, terrestrial sedimentary records are very few, so we are targeting the sedimentary deposits. And what we are seeing, the climatic changes, we are recording the tectonic processes and the surfacial processes also we see. And we do a field observation, then geomorphology and morphometric indices are taken in consideration to talk about the surface processes, and then a multi-proxy analysis, because you cannot just depend on one proxy when you're in such a region. So a physical, chemical, and biotic proxy is done, in which we do textural analysis, mineral magnetism, total organic carbon, and then elemental analysis. And because we need biotic proxies and polar because there is no vegetation. So palynology cannot be done in most of the lake systems that we worked on. So we did diatoms and palynofacies. And for chronology, we depend on the 14C AMS dates and the optical OSL dating. So as I said, that this unique setting, because of this, it can be deconvolved through paleoclimatic reconstruction to study the evolution through time. And that is what we are doing. So when we go to Ladakh, the geomorphology that we see is, you'll see, structures, landforms like these. We have U-shaped valleys. We have deflected stream courses. There is this fan toe cutting. Then there are abundant terraces, strat terraces also, fill terraces also. That's alluvial fan, debris cones, scree, talus, and lacustrine deposits. So, so now we come to the study. So this is, first I give you a broader picture of what is happening, and then to the centennial and the subcentennial data record that we had taken out from this area. So this is the typical, Shyok River Valley, where the Shyok is meandering. You can see these mega fans here, which are deviating the river to, meander, and you can see point bars and all. So what is happening is that Shyok, it comes from the remote tongue of the Siachen Glacier. It flows for about 400 kilometers in the Indian territory and leads to join Indus in Pakistan. So this is the longitudinal profile, and longitudinal profile is, it tells you about the role of the endogenic and the exogenic fossils. So in this, this is not a very equilibrium profile. So you can see that there are some points where the river has just, just cut the, gone very far in a very, very less distance. Like it has just, if from a higher elevation to a lower elevation, in less distance it has gone. So these are the neck points in the Shyok Valley also. But here we are not talking about the neck points. Here we would talk more on the overall, landform evolution of this area. So this is from here. I hope you can see my pointer. From here was the longitudinal profile that you had been seeing, and towards the eastern side, there is a big lake that is known as the Pangong Tso Lake. It is a valley lake. It's a big, huge lake of 165 kilometers, and the international boundary between India and China, it straddles over this lake. So Pangong Tso is like 45 kilometers towards the Indian side, and the rest towards the Chinese side. So it has been documented that during high stands, the Pangong Tso used to drain into the river Shyok via this little river drainage pattern of Tangzi River. So, but as of today, you'll see there are two different watersheds here, and this is about 100 meters. It has been separated. Yeah. So we all these points, the red points that you see, these are the areas where those were visited, and the sediment was seen what was happening. So in the Shyok Valley, when you go to these certain places, you see the paleo strand lines. And when you go nearer, you see a buff color facie that is clay and fine silt to sand, and layers of it, like meters thick. So these were possibly the paleo shorelines of a lake that one existed, that was one, once in the valley. And because, as I had said, that lots of physical weathering is taking place in this area, so the records are washed away by the debris. But in some streams, along some spurs, they are we can see them. So all this was documented. You can see a huge records of 40 meters, 50 meters, 60 meters. with some organic things to date, and these were the 16 paleolake sequences, 16 paleolake sequences all along the valley, and this is about 185 kilometers. Okay, so now I could because I'll just give you how was it. So this is towards the west, towards the east is the Pangong So Lake. And then you see debris, paleolake sediments like this, and sometimes they are big, huge, 40 meters, they are accessible. Some are not accessible. You could only, map them and see the paleo shorelines, huge. And as you go down the river valley, the height of these increase. They're found in a same contour. The contour is like 4,100 to 3,900 meters. So all this was mapped, and dating was done. So when you come to the last, the P16 here, this one, so what do we see is at this portion, after this, the river Shyok, which was like very broad, meandering, it was a typical U-shape, it was flowing in a U-shaped valley. It enters into a narrow gorge. There are several abandoned channels in this area, and also that this was the last point where such kind of facies that we call the lacustrine facies, or the facies of the paleo lake that once existed, is there, and it is like kind of blocked by a debris flow, which gives us an idea as saying that the debris flow had blocked this channel some 10,000 years ago. So all the sections were interlocked, and we got OSL ages from the fluvial and the sand beds, and the radiocarbon ages from the finer sediments, and more than 50 ages are there. You can see this. The circles are the radiocarbon dates, and the squares are the OSL ages. The blue, there are 5 types of facies that we divided the area into. The red ones are the fluvial sections, which are more of cobble, pebble, boulder facies, and both matrix supported or which are not matrix supported. Then there was this fluvial lacustrine sections, which had sand and silt and clay facies. The lacustrine sections were the ones which showed us massive clay and laminated clays and sections. And then we had some glacial sections, which were like till deposits and some moraines. And then the glaciofluvial and lacustrine together, where you see a kind of a mix of things. So if I take one as Pangong So, and these are the valleys, the Tangze Valley and the Agham Transact. These are the transacts that we worked on. What we see, putting everything together and dates together, we see that in the Tangze Valley at from 32,000 years to 20,000 years, there was a fluvial activity. Possibly, the Pangong was getting, and this fluvial activity is not like very, very thin. It is like massive cobbles and, terraces of them. So, and then after that, as the Holocene began, there was a phase of lacustrine phase which existed in both the valleys, meaning to say that the Pangong So had a western arm towards India. Okay, so the extent of the Pangong So was more towards the western side, and this was not like a small extension. It was in the order of 185 kilometers. And when we see that, so we see that during this time, the initiation could have been the ISM forcing, because the ISM is starting to come to the area. It was intense during this time, and you can see it from the Boulia isotope record also, and during the Holocene. So during the Holocene, there had been a big massive lake, which did exist till we have the upper dates of like 3,000 years. And so I just want to bring here is that in these kind of mountains that, the topography, it really changes fast. You see a lacustrine system, and then, few thousand years, there would be, it will change drastically. So there was this lake here, and then it was a connect to the Pangong Tso. And if we put it in this SRTM data, so this was the lost arm of the 185 kilometers lake. And if we see it, the Google images of the eastern side also, there we see that this big lake, the 165 kilometer lake, is shrinking towards us in the west also. So, this is one part of the story. So when you go to Ladakh today, you see certain valleys like this, which have a river and a village. But a few thousand years from now, they would have the scenario would be like this. And this is not only for the valley lakes, that because Pangong Tso is a valley lake and we were talking about a river valley, but here is an example of Sokar. Sokar is a closed catchment, okay? And lots of work by Mugvu Nirman in 2010 and later Mishra et al. In 2015 has been done from this area. And they have shown the hydrological evolution during the past 15,000 years. And here I've just taken two figures from here. Here, the light blue is the extension of the glaciers during this 15,000 years. Today, the glaciers are just on the boundary, this yellow line boundary, but they had extended till the lake itself during after deglaciation. Yeah. And then the extent of the lake was also very, very big. So even in the closed basin, the same kind of scenario has been, was there. There were huge, big lakes, which are not there as of today. So when you go to Sokar today, you would see something like this. It's not even a wetland. It's getting, it's getting arid. And this, if you see during at this portion, this is a village called Thukje village. It is a nomadic village. It used to be a nomadic village, but now there, because of the, lots of tourists and all in the area, it's getting bigger. But I recall that during one of my visits in 2003, 2, 3, and 4, I just had to walk for about 20 meters and I could see the waters. I would be in the waters of the lake. So in past 2 decades, this land has completely changed. It's become, there was blue waters and now, you can see greenery in that area. So this is what is happening to these places. Now we come to the Indus Valley. So this was about the Shyok Valley and the closed basin Sokar Lake. Now we come to the Indus Valley. What was happening here? So, so this is the longitude. This is the drainage, profile of the Indus Valley. Indus, as you all know, it originates from the Kailash Mansarovar. It flows to in the Tibetan region and then it enters India. And India, it flows to about 500 kilometers, and then again it leaves for Pakistan, where it flows and cuts the syntaxes, the Himalayan mountains, and then finds its way to the Arabian Sea. So the total area of Indus Basin here is about 25,000 square kilometers. And what has happened in Indus is a different story. So when you see different, along the cross-section profiles of the river, you see Indus as a broad valley, sometimes flowing in a broad valley, sometimes even broader here, but then it suddenly enters into a narrow gorge. And then, but if you see the lacustrine sedimentation, you see it all along the river. So let us see how it looks like. So this is the Tibetan Himalayan sediments at a near vertical, dip, and this side would be the Ladakh batholith. And the Indus is flowing like this here at a very narrow, valley to valley distance is not much. And what I and my team was interested in was this buff color fascia. You can see it at both sides of the river exposed. Because again, I point here that there is a lot of debris. Sometimes it's covered. Sometimes it's very hard to get the real section and the real picture of what was happening in these valleys. So I would just take you to a journey of, just about, the downstream Indus. So here, we only recorded the sections that were more than 10 meters thickness. The clay sequences more than 10 meters. So this is one. Yeah, I won't bother you with the names, but you can see how they had been covered, and due to road cutting or making bulldozers, they have been exposed today, and lots of them till where we could study. All these were later looked properly and seen and sampled. And I would like your attention that, the dates that we are getting, 17,000, 10,000, 3,000, 7,000, everything are after the glaciation, after the LGM. That is, the deglaciation after LGM. So in Indus, unlike Shyok, a different scenario existed during the late Quaternary. Here, the Indus was blocked at 4 different places. Okay, and there were different lakes that were found, and these are not small lakes. I'm talking about the lakes, the order of 40 kilometers, 50 kilometers of the valley width that had occupied. In these lakes are, because I said we are in the Himalaya and there has to be tectonic activity. So within the lakes, we find these seismites, which are deformational structures, which are convolute, dies, interformational folds. Microfaulting is seen. Then you have very complex convolutes like this. You have flame structures, etc. So they are they are bounded by undeformed beds, and they suggest a sedimentary deformation. And if we put all of them together, all in the Shyok and the Tanzir valleys, and all in the Indus Valley, and the other work of in the Quaternary Himalaya valleys, what we see is there a cluster around 27,000, 21,000, near about 1917, and then 10,000 and 6,000. So these are the periods which experience some kind of a tectonic activity, some kind of a seismic tremor in these areas during the late Quaternary. So now I'll come to a few case studies in which we'll see a more higher resolution of climatic picture. So one of the paleo lakes is the Khalsi Paleo Lake. It is in the Indus Valley, and we'll talk about it. It is 18. We could do a 18 meter thick section from here, and we had 5 radiocarbon dates. Here you can see the H depth model, and this is the section. And this basically is on the Eocene Cretaceous Indus Molassic sediments, and towards the north are the Ladakh batholiths, which are again Eocene in age, and towards the south is the Lama Uru Formation, which is Triassic. So this is the area, and what we were doing is okay, I think there was a figure actually. Oh my God. Okay, basically what we did was, we did a high resolution sampling. Slides are blank. Just a second, yeah. There was a figure. Okay, there was a figure which was showing the multi-proxy data that we did in it. So we did N-member modeling. So for N models like EM1 to EM4 were there, and which showed a very good variation. And EM1 was more clayey. It was it represented a clay and a stable lake condition with runoff from the with materials into the lake basin from the from the catchment. And then EM2 was a very finer silt, which was in the background in the entire section. Then EM3 was more of a aeolian silt, and when EM3 is present with EM2, it's more kind of a jet of westerlies coming to the area, and EM4 was more of a colluvial, fluvial post-grade thing. Then we did magnetic susceptibility in that, where KLF was associated and is associated with erosion and sediment influx from the catchment. Then we did for the grain size, we did some certain interparametric ratios, and also for the coarser grain size, that is multi-domain. We also calculated that to get an idea about the detrital origin, and then the frequency dependence of susceptibility. From that, we took out the biogenic and the pedogenic activities. Organic carbon isotope analysis was also done, and the delta C13 values, they ranged from -22 to -26 per mil, and paleo precipitation values were also calculated. I'm so sorry about this, but oh no, it's not there. Okay. So whatever variations there were, what we interpreted from the 19,000 to the section is from 19,000 to 6,000. So what had happened is from 19,000 to 11,000, there was a dominance of westerlies in this region. Okay, and there were, however, a small speck at about 17,000 during the early stage of the Heinrich 1 event. There was a wet phase, which is because of the ISM intervening that bigger westerly phase, and from 11,000 to 7,000, 11,000 to 7,000, we have this ISM that is in that region. That's what the proxy records, which I'm so sorry, the figure is not showing here, was telling us. So when I see a broader picture again, and this is 30,000 to today, and what I see is, the Lamayuru Lake was there, which was 35 to 24,000. Then the LGM. At LGM, we do not have any records in the Indus Valley. Of course, we have like moraines and all, but not dated records or worked on records as of now. And then after deglaciation, the lakes started forming in that entire valley. Some lakes are a result of the exogenic forcings, the climate, but some lakes were due to the tectonics in that region. And this is very well explained by the temperature curve, the monsoon intensity, and the Julia isotope curves by Thompson et al. 1997, Dodge, and the Pettit et al. Temperature curve. So the high lake levels that we are seeing from the lakes of Ladakh, whether it's the example was just from one lake. There are many lakes that were studied, and from Lahore also. Lahore is at the southern part of the study area from Chandratar. Lake levels are high lake levels are at 11,000 and 8,000. Okay. So now these were the paleo lake records. Now what we come to the Ladakh Range. What was happening that in the paleo lake records, we could not do much of the biotic work. So we said, let's focus on the Ladakh Range. And so we went to the top of the hills, where we could find a number of pro-glacial lakes. And this is the Ladakh Range with a number of drainage basins, more than 46,000, as I had told earlier. This is the crest line at about 5,000 to 7,000 meters. And we took from one of the largest basins and one moderate basin and one very small basin, we selected the lakes which were to be studied. So what has happened in the Ladakh Range is that there are no big glaciers as of today. During the summer months, it is ice-free. Only ice patches are there at some places. So the lake scenario, the pool of water would be at a certain place in this picture, we are at a height of about 5,000 meters. And, the pool of water would be just at one side, but there was a lot of fine sediments which was taken in for the paleoclimatic records. So these are the different lakes that were studied: 2 meter record, 1.8 meter, 1.9, and 1 meter in different part in the east-west range of the Ladakh, east-west transect of the Ladakh Range. So these are the ages. We got very good radiocarbon ages from there, and this is the age depth model. So again, here, something like this was for the Paleolithic slides also. I'm so sorry for that. This a suit of physical, biotic, and organic proxies were, we did it. So sediment texture with sand silt clay percentages, mineral magnetism for the activity and sediment input of the from the catchment, then TOC, nitrogen, and isotopes about the vegetation. Then we did palynofacies, in which the structured organic matter, the dark brown organic matter, the charcoal, zooplanktons, and bacteria were separated and counted as phytoclasts and pelanomorphs. And then, because as I said, we do not get pollen, so we did diatoms which were found a lot, and they showed a variation right from in the entire section. So a number of species, planktic species as well as benthic species were found in that, and then then it was converted into all these proxies were then run through Telia, CONUS, cluster analysis, and these 10 were selected for a paleoclimatic interpretation. So what are we seeing here is that, all these, this is susceptibility, this S ratio, clay percentages, and delta 13C. So what are we, I'll give you an entire picture. What we are seeing here is, from what we already know that from 7,000 till 7,000, what was happening in this area. Now from 4,000 to nearly 2,200, the northern fossing has been dominant in this area, which our records show us, because if you see some of the records that are mirror image of the GISP temperature curve, which by Groots and Stuvia here, and then for the other records from the southern part of the region, that is from the Himalaya, we took Katayat et al. And Srivastav's et al. 2017 records from the caves and from the higher Himalayas. So, and then the Tibetan Plateau records, just for a correlation and a regional, picture. So in this also, it's the 4.2 event, it terminated with a short wet phase as it is seen here, because the values of delta C enriched here, and the S ratios are also higher. And then there was a colder phase, and then again a slightly warmer conditions came here. But the entire time, the dominant fossing was the northern fossing, the North Atlantic fossing, and a number of stressed diatom species are seen during this area, this portion, and also charcoal activities. So what had happened was that, what we interpreted by this result was that during a colder phase in these mountains, there has been a human, the roots are active. The human is going from one place to another, because otherwise these valleys, they are such treacherous terrains, and during if the weather is warm and the glaciers are on melt, it is very hard to cross anything. So human activity is more seen during the colder time period till 2600 years, and after that the ISM fossing has dominated this area, this entire Ladakh area. There have been a number of records from different paleolithics that we have studied on the same lines, or the same protocol. These are different results that are already published in few papers. So what we are seeing is that there has been a decline in the there has been a decline in the lake levels, and there has been water stress condition. So a North Atlantic forcing is there, and then it has taken over at about 2600 and today it is the the monsoonal forcing that is acting in this area. When I see the data of the last century, this is the rainfall data. This is the average. Green is the average. Pink is the rainfall of the July, August, September months, and blue is the winter rainfall. And then we do have considerable precipitation from the summer monsoon also nowadays. And then on the other hand, when we see the temperature, we see this is the March, April, May temperature average. We see that it's rising. Even the January, February temperature is rising. What is happening is in the region is that the winters are getting warmer, and there is an early melting of snow. So till now, it was believed that 2/3 of the moisture from this area is from westerlies and 1/3 is from the ISM. And westerlies have dominated a major part of this land since quite long. And it also went till the higher Himalayas also, records show that. But despite this, the precipitation in the July to September is dominated by the westerlies. And this cannot be ignored. Yeah, and recently there are papers by on the water isotopic composition from the Shyok River and the Indus River by Pandey et al. And Sharma et al. So they show that it's the other way around now. It's like 26% contribution from the Mediterranean, and about 74% from the ISM. So this is something that has to be taken into account. So coming to the last few slides now. So, in Ladakh, in the Trans-Himalayas or in the hills like the Trans-Himalaya, which topographies are changing very rapidly. Rapidly, when we say the geological time scale, so, it's rapid, 10,000 years are nothing. So the entire fluvial geomorphology is changing into a lacustrine, landscape. So, and there had been blockades, and this is more in the Holocene period in both the valleys. So in the tributaries, there were big lakes forming, there were small lakes forming, and a lot of activity, geomorphic activity has taken place. So just to sum up everything, all the records till now, though it's not very updated, because recently many papers have come in late 22 and 23 from the area. So if I see the longitudinal profile of the Indus here, and I see the upper reach, the mid-moderate, the middle reach, and the lower reach, and then if I plot all the data that has come till now, blue are the Paleolake records, purple are the moraine that were dated for the glacial stages by Dodge and all, Owen and Dodge. And then these are the terraces, and then some Aeolian work has started by Vadia Institute, Kumar et al. So when I see all, and also the tectonic activities that have taken place, throughout the valley. So what we can say is that the both exogenic and endogenic forcings have been they have taken place, and tectonic activities we are seeing at 72, 50s. There are some dates for it. There is not any kind of cyclicity, but there is a recurrence which we are seeing in the entire area. And climatically induced topographic things are seen at MIS 5 stages also. Then there are reports at MIS 3 also, 2. And, all these lake formations when the Holocene came. So this is how the geomorphology or the topography of the area has been changing, which is a byproduct of both the forcings, the endogenic and the exogenic, as well as the westerly as well as the ISM. because records are very meager, we still have to work a lot in many records. Many good sections are there which are to be studied. But what till now, the major climatic phases in Ladakh can be summed as like this. So I conclude by saying that the Trans-Himalayan region could be a hotspot for observing magnified hydrological changes and respond to even subtle changes operative in the northern and the tropical forcings, that is the North Atlantic and the monsoonal forcings. And these manifestations can be seen in terms of observed surge of extreme rainfalls. So many hazards are happening. 2010, 2013, we see cloud bursts and incessant rainfalls in these areas. So these are posing a threat for the future. So it needs to be seen in details. So I end by this. And before leaving it for a question answer, I would like to acknowledge a lot of people, my funding agencies, my students, my colleagues with whom I've worked here, then the laboratory facilities provided by India, all over India, national facilities in India and in abroad, and all those collaborators who have helped me and worked with me, whether it was an objective related to paleoclimate or human climate interaction or permafrost mapping, analog of Mars or geoarchaeology. So thank you very much. I'll be ready to take in a few questions. Thank you.
Excellent. Thank you so much for your talk. So we'll let everybody type in their questions or raise their hands in the audience for those who are attending live. So I'll give you all a moment to think of some questions. I have a quick question while we're waiting for some. So I'm really fascinated by your record at Pangong and I was wondering if you had any evidence for outburst floods along with some of your lake deposits, because I know that I think there's even a couple people in the audience who've worked on slack water deposits in the Indus, because I know there's a couple around Zanskar, I want to say. But considering Pangong is so big, I wondered if you saw any evidence for that, because that's just fascinating stuff.
The flood deposits from the Pangong towards the Tangze, that paper is by Dodge. Those people, that group worked, and they showed that there was intense flooding at 11,000 years before present, because of the intensified monsoon. So what they've done, there are huge big boulders along that valley, which they did beryllium 10 of. And then they came to this result, because that boulder cannot be just, transported like this. It has to come through a flood or a high energy thing. So that is one of the papers, but directly, because I have worked more on the lakes, so I've seen them and I refer to their paper, but not worked there. But there are, certainly there are.
Excellent, thanks. Does anybody else have any questions? Oh, here's another one from Torsten Haverzettel. Would you like to ask your question out loud, Torsten, or would you like me to read it for you?
Sure, no problem. So looking at your last but one slide, so I've been looking at the terraces and on the lakes, and it appeared to me that stage 3 and stage 5 would be wetter than the Holocene. Can you make a comment on that? Would you agree, or would you say it's just a tectonic feature?
I would, I have to think about it, because my work in the Holocene and the last, late Quaternary, last deglaciation, so that has been looking at the westerly and the ISM. So MS3 and MS5 would have been wetter, but because in our area, we don't have much records of this size, this time frame, because there are few glaciations. Dodge and Owen, their group have worked in few glaciations in this region, And so there is a paucity of record. And for the lake sediments, where we could really tell how much would wetter or how much drier it would be, the lake records of that old, they are already washed away, or they are beneath the debris, which we really do not know. So for me, it will be hard to say whether it was more wetter or than the Holocene.
Okay, thanks very much.
Thank you.
Any other questions from the audience? So nobody's raising their hands. I have another quick question.
Yes.
You touched a little bit on this when you were talking about kind of the human, climate, and lake interactions. Do you know if there's been any geoarchaeology type of studies around the perimeters, maybe of some of these lakes at all? Well, although they're high altitude, you mentioned at the very beginning of the presentation that these were important trade routes, not only for like things like salt, but also just larger trade, essentially with Central Asia and East Asia.
Yeah, there have been studies have been initiated now, and very soon the results would come. The genetic studies, especially, there were these humanist tracks and the herds. The pastoral people, they were hunter-gatherers, yeah. So the herds were there. So they are dating the herds. And they say that the Archaeological Survey of India, they had a report some few years back where they dated a herd to about 8,000 years before present. So that old, yeah. So from then, there has to be some kind of a human, interaction in that area. And it is very hard to believe, like, why did human, want to live there? It is low oxygen, it's so hard. Then I think that, these big lakes, these freshwater for people. So this would be one of the attractions for people to settle in these valleys. So, there are certain links, and now many ideas are coming and people are working on it. And so for the archaeology also, people have started. There was a French group also, they have worked a lot on the rock art and petroglyphs and the caves in that region, but that is more of, Neolithic, more of historic. So the link between the Neolithic and this Paleolithic is like needed. So people are working. So maybe in a few years we'll have something to read on this interesting part also.
Fantastic. Yeah, I always think that, you see evidence of these lakes in such a harsh region. So it's naturally a place where I think that, yeah, maybe some ancient humans or just earlier civilizations of humans might capitalize on, especially there might be like animals, essentially, like the wetlands areas for people as well. So yeah. Fantastic. So are there any other burning questions from the audience for our speaker for today? No? Well, let's put our hands together and thank Dr. Binita Phartiyal for her wonderful talk about all of the work that she and her team have done in Ladakh over the years. I look forward to hearing more about what your team is putting out. And I guess I'll wish everybody a great rest of your, again, afternoon, evening, morning, wherever you're tuning in from. And then next week, I believe we are also have another monsoon series seminar at the same time. I'm pretty sure that it's also going to be kind of along the Schedule B time. And I believe I'm also hosting again. So I'll see you all next week. So thank you again and have a great rest of your